So, hi everyone, once again, another day. What today I'm thinking, I want to tell you a story about a balloon, like in the form of a lecture. I want to condense that lecture into a storytelling. So, let's understand the properties of a gas dynamics, are the basics of a gas dynamics. So, there was a balloon called Balu. It's a traveling balloon. So, like imagine like it's a small orange color balloon. So it's wanna travel the whole world. So, um, so what? How a balu? Balu is made up of a simple a collection of air inside the balloon. It's balu, separated from the outside world. Uh, outside world. So what is inside the balu? Inside, so balu contains air, molecules, particles, and so many other like hydrogen, oxygen, nitrogen, etc. Outside the balu, we call it surrounding. So balu skin basically contains rubber, skin type rubber. So we call it boundary condition. And the properties which balu acquires are pressure, temperature, volume, and mass. So how hard pressure? How do we say? So how hard his air pushes from the inside. Temperature, how warm or cold he feels. Then volume, the space balu takes in a surroundings. And the mass, the amount of air it makes up. And the mass, so the air that contains like specific volume, how much special each kg of air occupied inside balu. So what happens when balu, so first starting balu is moving from a cool mountain to hot plain air. So what happening over here in the mountain, so the mountain is cold and low air pressure, so balu might shrink, so the molecules inside him they might shrink. So low temperature and pressure decreases, so volume decreases. So when he moves to a plane, so planes are like hot and high pressure, so he expand. Higher temperature increases pressure and volume, if not constrained. So balu learned that if he stays at the mountain, he will shrink, and if he comes to the like deserted area, he will expand. So from this we can like create the magical formula like equation of states where pressure, volume, and temperature related, called the equation of states. So for an ideal gas, like balu is made up of an ideal gas. So we can consider it like PV equals to nRT. So P for pressure, V for volume, and for molecule of gas, R for gas constant, and T for temperature. So next, gas constants and universal gas constant. So these are two kinds of gas constants are there. So first thing, like if balu is fully made up of oxygen, so what will be his weight? Otherwise he is fully made up of hydrogen. So hydrogen, we know that like hydrogen is lightweight than oxygen, so it will float. Otherwise balu is fully made up of carbon dioxide, so what he will do, he will like descend down and he will stay at the ground level only. So like that every molecule have its own mass. So on basis of that there, so we have two kinds of gas constants. So first is gas constant and second is universal gas constant. So first gas constant is based on the molecules of a each. like one molecule, like one kind of molecules have a different gas constant, and other molecules have a another kind of molecules. So to get that molecule, we use a like universal thing like universal gas constant, which helps us to find the individual. So then after, so that universal gas constant value is 8.314, which we have to do some mathematical calculations and all sorts of stories. And then after, Barlow moves to changes state thermodynamic process. We have Barlow places something temperature, pressure, and volume. We have discussed now. So the temperature, pressure, volume, those things are like correlated to each other. So if one thing stays constant, so other things might change. They will change. So if we take the temperature remains constant, so we call it isothermal, where the pressure, volume, they will change. And if volume stays constant, it called isochoric, so the pressure and temperature will change. Next, isobaric, where pressure stay constant and the temperature and volume they changes. And there is another one like adiabatic, so there which no heat is happening over there and no friction is happening. So like this process teaches Barlow a new thing. Next is type of systems. So Barlow get to know that like it is made up of air, and it can only like transfer its air by like blasting. So there are some kind of systems are there. So three kinds of systems are there. Closed system, which Barlow doesn't exchange air, only energy he can exchange like heat. And open system, where Barlow has a leakage or an opening valve, both air and energy passes. Next, isolated systems, like Barlow zipped up inside a thermostat, like Barlow is in space. So Barlow learned a big lesson. Wherever Barlow goes, like mountain, valley, or cities, how his state properties changes depend on his location and the type of changes the environment makes using the gas law and equation of state. We can predict how long, how big or small, hot or cold Barlow will get by this process. I hope that my learning of the gas dynamics in the way of a storytelling is okay.